Why do some objects float and other objects sink? I wonder if you ever thought about this before. If you take some water and you take a ball, say a small steel ball, and drop it in the water, it's going to drop to the ground. If you take another ball, say a beach ball, it's going to sit on top of the water and float. And it might be that these balls have the same mass. So a ball will not float or sink just because of its mass. The reason that a ball might fall or sink is really because of its density. The 8th chapter in AP Physics 1 is all about fluids, and we're going to consider things like density and pressure and look at the equations for that. And the first formula we're going to talk about is density. The density of an object is given by the formula rho is mass divided by volume. Rho is a Greek letter which stands for density. I don't know why it's rho. It's actually the Greek letter for R, but it's kind of a P with a curly thing on there. And it's just equal to mass divided by volume. So if something has a larger mass, it's going to have a higher density. But if it has a larger volume, it's going to have a smaller density. The units for density are going to be kilograms per meter squared. The units for density are going to be kilograms per meters cubed. Let's think about that example I said at the beginning. Here's a big tank of water, and we can already begin by saying, what's the density of water? Now, it's a little bit different, but approximately 1 kilogram of water takes up 1 liter. In this chapter, we need to think carefully about our units. So what's a liter to meters? So a liter is going to be 1,000th of a meter cubed. So to calculate the density of water, we put these numbers in the equation. We actually get 1,000 kilograms per meter cubed. Okay, let's imagine a little steel ball. And let's see what the density of a steel ball is. Let's say we measure the mass of this steel ball and the volume of the steel ball. Let's say the ball has a mass of 8 grams and the volume is very small. If we put these numbers together, we calculate that the density of steel is going to be 8,000 kilograms per meters cubed. So the steel ball has a density that's larger than the density of water, so it's going to sink. And it'll fall all the way to the very bottom. Now what about the beach ball? It's going to float. Now let's say we also measure the mass and calculate the volume of the beach ball. So let's imagine, for the sake of this example, that the beach ball has the same mass, say 8 grams. Let's imagine when we measure the volume of the beach ball, we get 0.25 meters cubed. So what's the density going to be? It's going to be much smaller. Wow, that number is way smaller. So the main idea here is comparing the densities. The density of the beach ball is much smaller, so it's going to float. The steel ball is more dense than the water, so it's going to sink. So whenever you're thinking about floating or sinking, the right frame of reference to use is density. We can also compare, say, 2 liquids that are floating or sinking. Let's imagine we have 2 cups. One of them has water and the other has some oil in it. Now, water and oil have different densities. Water has a density of about 1,000 kilograms per meter cubed. Rho has a smaller density, of about 800 kilograms per meters cubed. So what happens when we mix them? At first, it's all going to be sloshing around, whoosh, kind of mixing like that. But if you wait a little bit, they're going to separate over time. And the one with more density, the water, will be at the bottom. The one that has a less density will be at the top, oil. So these liquids will float and sink on top or over each other because they're different densities. The greater density is going to be at the bottom, sinking sort of, and the lighter density oil is going to be floating on top of the water. The best way to get an A on a test in physics is to do a practice test. On my website, there's a free practice test for fluids. If you click the link below, you can get the free practice test. We'll even mark it for you and let you know how you did. I wonder if you can think of any examples of density in your life that you've seen. Anytime that you've seen something float or sink because of density, or anytime you've seen things where density affected what happened. Why don't you write in the comments below a time that you've seen density affect something.